Cylinder head porting is the process of carefully modifying the intake and exhaust ports, along with often the combustion chamber, in an engine's cylinder head to improve airflow, increase volumetric efficiency, and enhance overall engine performance. Factory heads frequently contain rough casting imperfections, restrictive shapes, and port mismatches that impede high-speed gas flow. By smoothing these areas, optimizing port shapes for better velocity and volume, and ensuring proper transitions, porting can deliver noticeable power gains, typically in the range of 5 to 15% or more depending on the extent of the work and the specific engine application. Carbide burr tools, also known as rotary files or burrs, serve as the primary hand tools for this work. They consist of tungsten carbide cutters used with high-speed die grinders and excel at efficiently removing material from aluminum or cast iron heads, making them ideal for roughing, shaping, enlarging ports, removing casting flash, and blending surfaces. Carbide burrs offer significant advantages in porting because they remove material faster than abrasive stones or rolls, allowing precise control in tight or deep port areas. Their various shapes, such as tree, flame, ball, egg, cylinder, and taper profiles, provide versatility for different sections of the head. Double-cut burrs work well for general purposes and produce a decent finish, while single-cut or non-ferrous designs help reduce clogging when working on softer aluminum. However, they are aggressive tools, so it is easy to remove too much material if not used carefully. They are typically followed by finer abrasives like cartridge rolls and flap wheels for smoothing and polishing. A proper setup includes a high-quality die grinder, either pneumatic or electric, with good RPM control, often 20,000 or higher, extended reach burrs with 1/4 inch shanks, lubricants such as grinder's grease or paste wax to prevent aluminum from clogging the teeth, and safety equipment including goggles, a respirator, ear protection, and gloves. Additional tools like intake and exhaust gaskets for matching, calipers, scribes, and ideally a flow bench help guide the work and verify results. Before beginning any porting, it is essential to follow key principles to avoid ruining the cylinder head. Less is often more, as over-porting can reduce air velocity and hurt low-end torque, or worse, break into water jackets. The focus should remain on smoothing imperfections, gasket matching, improving the short side radius where the port turns sharply toward the valve, and gently unshrouding the valves in the combustion chamber for better flow without excessive material removal. Air and fuel mixtures behave like thick fluids at high velocities, so smooth transitions and consistent port shapes across cylinders matter more than simply making ports as large as possible. Material type influences technique. Aluminum cuts easily but clogs tools quickly, requiring lubricants and lighter pressure at higher RPMs, while cast iron demands more aggressive or finer tooth burrs. The porting process starts with thorough preparation. Disassemble the head by removing valves, springs, and other components while protecting valve seats and guides. Clean the head completely, then bolt on the intake manifold gasket and scribe the port outlines onto the head to guide material removal for proper matching. Mark restricted areas to avoid, such as thin walls or pushrod passages, and secure the head firmly in a vise or stand under good lighting. Begin rough porting and gasket matching using tree or flame-shaped carbide burrs to remove casting flash and gradually open the ports up to the scribe lines. Work evenly around the port walls, keeping the grinder as parallel as possible to the surfaces and using light pressure with constant side-to-side motion so the tool does the cutting rather than forcing it. For aluminum heads, periodically apply wax or lubricant to the burr to minimize clogging. Next, move to bowl blending and valve area work. Use smaller burrs to create smooth transitions from the port into the valve bowl, paying special attention to the short side radius for improved flow characteristics. In the combustion chamber, lightly unshroud the valves by removing material around the valve head, but switch to less aggressive stones or rolls here instead of carbide burrs to prevent over-removal or damage to critical areas. Old valves can be inserted to shield the seats during this step. After the main shaping with burrs, transition to smoothing and finishing using progressively finer abrasives such as cartridge rolls starting at 60 to 120 grit and working up to 320 grit or higher. The goal is a uniform surface finish. Intake ports are often left slightly rough to aid fuel atomization, while exhaust ports can be polished smoother. Deburr all edges thoroughly and clean the entire head to remove any residual grit or metal particles. Throughout the process, maintain proper technique with carbide burrs by operating at recommended RPMs based on burr diameter to avoid overheating or clogging, using two hands for stability, and keeping the tool in constant motion to prevent grooves or uneven spots. Common burr shapes include tree profiles for main port work and radii, ball or egg shapes for contours and blending, and cylinders for straighter sections. Advanced techniques may involve blending around valve guide bosses or optimizing flow to match the intake manifold. After completing the ports, inspect for uniformity across all cylinders, measure combustion chamber volumes to ensure they match, and ideally test on a flow bench. The entire job can take many hours or even days for a beginner, so practicing on a scrap head or a single port first is highly recommended. Safety remains critical during cylinder head porting. Flying metal debris, abrasive dust, and loud noise pose significant risks, making full personal protective equipment and good ventilation or dust extraction essential. Common mistakes to avoid include removing excessive material, creating uneven ports that cause flow imbalances, damaging valve seats or guides, or neglecting to clean the head properly before reassembly, which can lead to engine damage from leftover grit. With patience, attention to detail, and respect for the tools, carbide burr porting can significantly improve engine breathing and performance while preserving the structural integrity of the cylinder head.
Thanks for watching. If you're looking for high-quality American-made carbide burr tools that are built to cut faster, last longer, and help you get the job done right, visit our website today. We keep our American-made carbide burr tools in stock and ready to ship, with same-day shipping available on orders placed before our daily cutoff time. Whether you're working on metal fabrication, porting, welding, automotive projects, or precision grinding, we've got the carbide burr you need. Visit our website and order yours today.